it's my turn to introduce the next presenter. Her name is Terrell Wong. She's an architect with over 30 years of experience. Her passion for the environment and design has greatly influenced her career. In 2006, Terrell led the winning team to the National Archetype Sustainable House Award. Their building blocks modular home concept was constructed at the Toronto and Regional Conservation Authority Courtright Centre as a showcase for sustainable design. Terrell was a founding member and is the president of Passive Buildings Canada, a national membership-based nonprofit organization that promotes the passive house concept. Recently, Terrell published Passive Buildings in Canada. This book is a snapshot in time of these buildings in Canada. The good is to present these excellent designs in an early, comprehensible way to architect, engineer, builder, and future homeowners alike. This book encompasses buildings from British Columbia to Nova Scotia and building types on diverse as single-family dwellings to high-rises. So, Terrell, welcome to the stage.
Thank you very much. I'm kind of excited to be here today. Adam Cohen couldn't make it, so in the last minute I sort of, okay, I'll do your speech, but now it's my speech. So, now we're looking at it through, the projects that I've worked on, and I know a lot of the companies that I'm going to talk about a little bit. I have relationships with many of them, so I wanted to make that clear. I also want to give a plug to the Green Building Learning Zone that's outside. So if you have questions about interesting materials and you want to talk to architects, builders who have got together and have been giving this information away at conferences, it's there. Go touch the materials. We have mycelium, which is a mushroom-based insulation. There's straw bale, a lot of low-carbon materials that you can see for the first time or talk to some expert about. So I just wanted to give a little plug there. And then I'll try and start the speech and speak as slowly as I can and enjoy it. I think this is for me. So what is passive house in terms of construction? Passive house design is currently really nothing more than very high-end custom design. The projects come with bespoke engineers, bespoke thermal modeling, architects, and contractors. In our traditional model, the architect seems to work alone in his silo, and only after the basic design is completed and the clients have buy-in, so there's some weight to it, do we call the team together to shoehorn in these mechanicals and structural. But this is one of the very most expensive ways that we build. Passive house design encourages integrated project design, and I know a lot of people are starting to embrace it, where the team members include the clients and we're working together from day one so that we can step forward and move forward, reducing the costs associated with over-design and unresolved details. Some of this may cause more upfront costs, so because we have the engineers and the contractors and the owners all at the beginning, but I think the results usually speak for themselves. I made the assumption when I'm doing this speech that everyone knows the basics of what a passive house is. So I'm not going to go into physical details on passive house. The magic words of custom construction, we know it, on time and on budget. I've never actually been able to get those words out and feel like I can meet those criteria because we have issues like our standard construction methodologies where we're have so many different sub-trades coming together. We need air barriers at certain times, and then we have electricians that poke holes in the air barriers. So this just shows one of our, a standard stick-built construction, trying to get the air barrier in the basement and the insulation in the right places, and the vapor barriers, and all these other things. And we keep having to do these things, and we're coordinating the whole time to make sure that this is on time and on budget. But things get in our way. We have weather. And when we're on site working, these kind of conditions are not conducive to the types of detail-oriented work we must do for higher efficiency buildings. People are not in their best when it's raining or it's too hot or they're overcrowded getting things done. So that's not going to be on time or on budget. Material storage on any site becomes, quite a huge issue in some requirements, because you're trying to manage this timeline that we're doing things in. When does the air barrier go in? When does the vapor barrier go in? Where are we putting the insulation? And sites are tight, and we're having a hard time dealing with it. So things aren't going to be on time or on budget. Waste. Having that as part of the construction company's mandate is great. It takes a lot of time, it takes a lot of energy in dealing with the recycling, and we have a lot of it. So this, we're not going to be on time or on budget if we can't deal with the waste stream on the sites. And also material procurement. Coordination of trades. I had that one next. So the coordination of trades is, you have an electrician, you've got a plumber, you've got framers, you've got air barrier people. They're all working on top of each other. I love these pictures. I thought I couldn't find the serious pictures of plumbers and electricians, just weren't doing it for me. So, and in our more complex world, people want smart buildings, they want all these gadgetry things, and everybody on a passive house site has to be on board with having an airtight building, energy efficient building of any type. And I'm picking on the plumbers and I'm picking on the electricians because they're putting holes in my building on a regular basis. And one of the things that we do on passive house sites is have somebody in charge, being the air sealing person on the site, to make sure that this is constantly happening. You're making sure that these holes are being plugged and filled in. But it's difficult to do it in a site condition. Client change orders. These are my favorite. You've got a building permit. These are actual drawings from, I had a building permit, and the client said, could we just make this room 2 feet wider? And you're thinking, that can't be too hard. And then you're thinking, no, this is a 4-dimensional problem. You have time, you have space, and I've got to deal with. Now you've done everything with the energy modeling to make it a passive house. You've done everything with the engineers. You've done everything right, and at the last moment, we're going to change this. Those 4 ovals represented something that I thought was going to be easy. And one of the things we did was build a 1-story structure attached to a 2-story rammed earth structure. And rammed earth there was a bit of a thermal bridge between the two. And so we decided, okay, we'll use some aerated concrete block, and we'll put that and we'll ram it right into the rammed earth wall. And it's going to be hidden because we have this drop ceiling on this studio that's now 2 feet wider. And we're going to put the mechanicals in there. You won't see the aerated concrete block. And I thought I had it all covered. And I always tell my clients, it's like picking lice out of hair after you've finished a set of working drawings, to go back in and make sure you get everything. So we did. We got the extra permit, and everything went well. And then the client said, oh, I like the cathedral ceiling. And so now we have aerated concrete block as a feature on one of our walls. So you can never know. These things are hard on all of us. And when we're doing integrated design, we want to make sure that we've got everything covered and we're going in one direction forward. So next level construction methods, I think, is kind of how we're going to have to go forward. Because if we're stepping over each other and we're leaving stuff on the site, then what can we do to make this a little bit easier? So pre-designed structures is one way of thinking about it, and prefabricated panelized structure is another way of thinking about it. You still have weather, but there's a lot less. So in a prefabricated building or a panelized building, we're working in small factories. I mean, I work in small scale buildings mostly, so a factory just is a roof, it's dry. We still have the same carpenters in the same spaces. They're still doing the same jobs, but they're building never in the conditions of a rainstorm. You're not building it when it's 30 degrees outside. So with the weather the way it is, this is the place where we can take that a little bit out of it. The material storage becomes a little bit easier because now we have a building in which we're dealing with it. We know what the inputs are, we know what the outputs are. Coordination of trades becomes a little bit easier. Mostly when they're building panelized, or the ones that I've dealt with, the electrical and the mechanicals aren't part of it. I see this as some potential for the future, where we're looking at panelization that includes a click and play of that sort of thing. Materials procurement, as I said, is a little bit easier. But buildings are made out of bricks and mortar and wood, bricks and sticks, as my son says. And it's the same number of bricks and sticks for a building. So if you're trying to squeeze money out of a project, it's not going to be in the materials. You can optimize to a certain amount, and if you're a large enough company or you're building in a panelized way, you kind of have less waste, but you're looking maybe at a 10–15% reduction in costs to building these type of buildings. And client change orders, when you have panelized structure, my suggestion is that the penalty is huge, so that this is reduced to a minimum. Because if you've already started building these wall panels and roof panels, it's going to cost a lot for those clients to change their mind. So perhaps it'll be easier on me in the future in that regard. So I'm going to go through a few companies that I have worked with or that I know of that have done some interesting things, and they're all a little different. So this is Aiken Frame Homes, and they use attic trusses, helical piles, and a different construction season to reduce the cost and provide affordable housing. And she's an international company, but she started out in Muskoka. So what they do is you build you the top half of the house first, and then you live in it for a little while, and you have a kid, or your life circumstances change, and you need some more space. So they pick the house up. This is a project at a school, and it actually is going to be a dormitory underneath this one. But for the most part, they're single-family homes where they lift the house up, and they can build in the wintertime when the construction industry is usually less active in the areas where she's working to benefit from those cost savings. And so I think I have a picture. So then they fill in the first floor with some of these panels that I've talked about, where they can put, these ones are from Took Tree, a company up in Muskoka, and they were put in on the first floor with the openings for the windows. But there's another level that we can go to with panelized projects, that not only do they just make the walls, but they can add the windows and some of the finishes. So I see that as a future for panelization. But panelization is still a little bit custom, if you think about it. This is showing some air barriers a little bit in the spring. They'll keep adding to it. In that every time you go to work that day as a carpenter, each wall is going to be different. There's no widget that I'm making 30 of these today and 40 of those tomorrow. So although panelization is a really great idea for quality, if you're building something different every day, there's learning curves, there's time, and there's an expectation of, getting up to speed on the next project. The next pictures are some of the future versions of Aiken Frame Homes that we're working on that reduce the complexity of the projects. Just showing some examples. And these homes, because they're on helical piles, can go on sites that otherwise would be considered unbuildable or undesirable. One of the company's ethos is to build affordable housing. And so up in the Muskoka area, they're buying all those lots that are not on the water, that are rocky on one side and soft on the other. And they use post-tech helical piles to make sure that all of their designs can be built there. And their thing is they have a certain set number of designs, so within a range of 12 types of houses. This is another idea of a pre-designed house. I've worked with Eric Cura before and designed this Freya home. We've done at least 3 iterations of it at this point, but this is a rammed earth house. Rammed earth is a very physical labor on-site thing. They're not taking the site out of this one. But because they've designed it, 3-dimensionally measured it, figured out all the materials, decided on all the locations, and each site becomes another way to practice and learn from what you did before, that each iteration of this house is getting better. And so they've got it down so that they know what the cost is to the homeowner and where they can build it. So lovely. So panelization, we're talking about, this is Simple Life Homes. They make all the panels. They're passive house rated. So they're all designed for the site that they're going to. They design them in 3D so that they can see where it's going in the building and how it relates to the interior walls and where the windows are and how it's going to fit. And your ability to get to that, I always think of house construction on site as being, well, it's within 6 inches or it's within 3 inches. This is a little closer to industrial design where you're thinking about millimeters now instead of being out of square, that sort of thing. And so they bring them to the site and they're part of the installation process. So it's a new way of thinking of what carpentry is and how carpenters work on site. So here's a factory of pinwheel structures. They're in St. Catharines. So as I said, it's a place where you can start building buildings on, oh, sorry, I can see it here, you can't. There's the factory for pinwheel structures. And they do the same thing that the Simple Life home does. They're creating structures. They're adding a little bit more sometimes now with finishes on the outside of the building. So you can see the same wall going up. And they've got the equipment to lift these larger pieces and bring them to the site. So I think that this idea is a great idea, and I think you need to take it to each of these companies is starting out. They're very excited about what they're doing, and they're all going to be going to this next level. So Build Smart, which Adam Cohen, who was going to do the speech, started many years ago, decided that we should have widgets, that panelization should be limited to a small lexicon of parts, an IKEA version of the envelope components. So you can pick and choose from the foundation to the roof how you're going to build your Build Smart home. And it includes everything that you see there, including the passive house grade windows. And by limiting those numbers, picking through it, an architect or a homeowner can pull together different designs. So the homes are still custom, the buildings are still custom, and it doesn't matter if it's a one-story structure or a multi-unit residential building. The parts are all the same so that you can create these different structures. So this is less chance. So here's a larger structure. This, I believe, is the Blossom Park building, showing some of the smart panels being put up. So you can see that even on larger scale residential, these panels work. So I think some of the nicer upgrades for the future would be when panels come completely finished. This is a picture showing how these prefabricated passive house panels can fit into a CLT building where they click in place and then the building gets finished quite easily. So CLT construction is what I'm going to talk a little bit about next. The companies that are now working in prefab passive house market right now, I'm going to just give you a very short list. There are tons more, but these are the ones that I'm aware of. Some of the ones that I've already talked about. Build Smart, Quantum Passive House, Took Tree, Simple Life Homes, BC Passive House Collective Carpentry, Aiken Frame Homes, Agora Construction, Maison Element, Pinwheel Structures, and Element 5. Passive Buildings Canada, the other organization that I run, has lots of articles on really interesting topics in passive house, and there just happens to be one that we put up based on the prefab panelized market that's in Canada right now. So I think that's a really good thing to check out for more information and this list of companies that is working in it at this point. So now we want to think about something that's beyond panelization. What if we design buildings more like industrial products, but in the best way? So with low carbon materials and with time-tested prototype, then test, and then manufacture, and then learn from it, taking lean principles, repeat until the product gets better each time. We're going to have tighter tolerances, no discrepancies between what the architect has drawn and what actually gets built. If there's a building out there that I've designed that even matches my drawings, I'm quite happy. But whole sections of the building can be prefabricated and shipped directly to the site for installation. These are showing the one on the far right. I have to turn around for that sort of thing, spatially inept architect. Is the 18-story structure in BC going up with the CLTs and the engineered wood. And I love the fact it's kind of going back in time, but with modern materials. I really enjoy that. And the other one is showing CLT structures where the windows and the doors are all pre-cut. CLTs are very exciting. Right now, they have a playground here at the Carpenters Union, and I got invited to go and play in the playground with all the carpenters. And I was quite surprised. I've been very lucky in the last few years to get to know a lot of German manufacturers of CLT products. And I had these expectations that the CLTs would be finished, that the details would be hidden, and all the fasteners would be hidden. And I got to go to this thing, and I really did enjoy it. It's always fun to watch people building. But they were using skill saws to cut the CLT. And I'm like, why would they do that? I think it was partially because of the timing on this one. But CLTs can be put through, more CLT construction, can be put through a process with, this is the simplification here of how CLT structures go in compared to the earlier design, showing all the finishes, making it more simple, and then it went ahead without me. Perfect. But this is how we should be building with CLTs, where the factory no longer is just a cover for the carpenters, but you're using CNC machines that do everything. They're routing out the jam around the doors so that all that you have to do when you plop the interior walls in the building is stick the door in. It already has the reveal. You've coordinated with the mechanical engineers for where all the openings are going to be. The electrical outlets have all been pre-designed for you so that you can route the electrical through the building. And it's all done through that integrated design process. Where you spent that time up front, I had the opportunity to work in Pickmobert near White River, Ontario, where we designed 5 houses, and I was in charge of doing the shop drawings for the CLTs. Most nervous time in my life. That I can do a design and architecture and hope the electricians get it right. But I had to draw every single panel that had to be built in that house, showing all of the holes, all of the doors, and so that they could put that information into a computer in a totally different country at this time, because it wasn't available to us here, so that I could not be so nervous when those panels came over on a ship to be put into place. Very kind kind of scary, but it works. And then so here's a really interesting company that I love and I'd love to use. I've never used it, but they take CLTs to a little bit different level, and they make these little box beams out of prefabricated box beams, and they can fill them with fire retardant or sound retardant or insulation materials to create floors. So the one where the gentlemen are holding it, that's in a retrofit situation, and it's only 8 inches wide, but it can be up to 12 meters long, and you can put a new floor in a building that's insulated or soundproofed. Or they make them 1 meter wide for new construction, and you can build up the floors that way. And they come with more than just insulation in them. They can come with, as I said, the fire retardant, but you see the one where the bedroom is there with the sloped ceiling, so it's not just floors, it's ceilings as well, where they add in acoustical patterns depending on what type of space that you need. So if you're in a yoga studio, it might have a different pattern than if you're in a theater or something like that. So these things are being done based on this new digital age that we're coming into in construction. So these aren't available here unless you know somebody, but it's the future. So I think it's really great. One of the things I've also been able to do is start to look at prefabricated components. So these stairs were actually designed in Toronto, and we'd have meetings, integrated design meetings, with 3 different companies to make these stairs that were all located in different places in the planet. And so the metal company had to understand what the wood company was doing to make the steps, and the glass company had to come together so that the wood would fit into the glass on a curve. So this is possible, although scary, that we could measure this site with a laser and then come back 6 months later and build this staircase in a few days, because it was pre-finished and pre-done. So here is the next level here. So we've got Sure Pods. These are bathrooms that are fully designed with the plumbing fixtures. They practically have the toilet paper in them. They are shrink-wrapped and sent to a site to become the bathrooms in a high-rise building, so that they're already done. Everything's the same. We don't all have to have a special bathroom. We're okay. The toilets work the same way. So I think it's really interesting that we can do that with bathrooms, and we can do that with kitchens. So these are actually made in Ontario, and they come to the site as you see them there, and all you have to do is plug them in. They come with the appliances already installed. The backsplash is already there. Everything's already done, and the cabinets aren't designed as one 3-drawer cabinet, one this cabinet, one that cabinet. They're all designed as one side of the room. And how they pack them and how they send them makes it easier to build. So I'm very interested in trying to get somebody to do this on one of my sites. I think it's really interesting. This is an interesting company that takes the prefabricated idea and mechanizes it. So these cabinets here would be for a small studio apartment, and you could turn it into a 1-bedroom. So you push a button, and the bed pops out on one side. And you push another button, and the whole thing moves in a different direction. It becomes a walk-in closet. And then it moves again, and it becomes an office or a living room. So all these parts move, and they're working with, I believe, IKEA to sell these for multi-unit residential projects. And I thought, well, what else is missing in our buildings that aren't prefabricated? I didn't think I'd find one. But I was thinking with high-rise buildings, we would be needing prefabricated stairs and prefabricated elevators. Never did find the stairs. But there are companies out there that do in metal and in concrete prefabricated core construction. So the one picture where the Phoenix on the right-hand side, that's a school where they didn't want to stop school during the year, but they needed an accessible elevator for the building. So even while school was going on, they just had to prepare the hole, and they plopped the elevator in, and it was a retrofit situation. It's very interesting. And then we've got, I think this is sort of in the future, I don't know if it's actually happened yet, and I'm not a mechanical expert, but I see in the future that there are mechanicals are the things that, I mean, you can have an apartment all you want, but if you can't get the water into and out of it, if you can't get the waste out of it, we can build prefabrication all we want to, but we need to get that next level of prefabrication in there, where the plumbing, the mechanical, and the electrical stacks can be tilted into place, and we design around them instead of trying to shoehorn in all of this complicated, crazy, and really putting our designs at an equal level to the mechanics of the building as well, so that they function really well. These are designed so that in the hallways of the apartment buildings, that the person servicing it has access to it in a way that they're not disturbing the people in their units. So these are things that I find really interesting in terms of future. And then I get to the really crazy stuff where let's build the whole unit, the outside, the inside. This is a Marriott hotel going up in New York. The toiletries have been put into the modules before they get lifted into space. It's crazy. This is a 90-story building where every day they will complete one story of the building in downtown New York, and they will have it designed so there's two sites, I would assume, where they truck in a unit every hour until the end of the day. So there's not that, there's never on a high-rise building, one of the big costs is all the safety equipment that you have to have for all those people hanging out. And this is designed so that once these are in place, you're an occupied building. So you don't have that. So this is where the savings come in as we look in the future. You're getting higher quality at equal price if you're talking about something at the level of panelization. But when you're getting to this level, you're saving 30%. You're starting to see those bigger numbers because you can build this in half the time, 30% less of the time. So they built the bottom half, which you can see here, that's the finished building. And it's not a boring building. I mean, you don't have to make modules boring. Just by tilting it that little angle at the top kind of gives a dynamic flow to it. But the bottom 3 stories and all of the underground work is happening. While in Poland, they are building all of these units and putting the beds in and putting the toilets in and putting all that stuff and lifting them into place after the stuff on site has done. So if we can reduce that amount of stuff that happens on site, we can reduce the time that we disturb the cities where we're building these things. So this is another company out of Australia, Hickory Group. So it's the same idea. They're building multi-unit residential. The missing middle could be built in 3 days. Think about it. Where they're lifting the units one at a time, and the buildings aren't boring. And they can be insulated to any level you want, so that using these methodologies, it would be really easy to get to energy efficient levels with the quality, the consistency, and with compartmentalization. That's another thing I'm thinking about. These things that really help with the compartmentalization of those air barriers and vapor barriers, and that idea that you're not smelling something down the hallway, or you're not undercutting doorways to make this happen. This is sort of taking it to the next level. So I think I got ahead of myself here. The last thing is the future of the construction industry is changing. The nature and definition of what construction worker is will have to include working in high-tech factories where the quality controls ensure far superior products. To meet the higher quality demands of energy-efficient designs within tighter budgets and time constraints, we will have to adopt greater integrated project design, embrace multi-platform technologies to create structures that are on time and actually on budget. But, big but, only in the reduction of our energy use, the waste, and the embodied carbon of the materials we put into our buildings can our industry be part of the climate solution. Thank you.
Okay, thank you very much, Terrell. Is there any questions? Oh, I think we have somebody dashing for the microphone there. Leon.
Thank you very much, and thanks for an excellent presentation.
Thank you.
I was wondering if these design principles and these design building techniques have been adopted for remote northern First Nation communities in Canada, where you have the dual challenges of a very short construction season and energy, especially heating, is at a premium.
Exactly. Well, the work that I did in Pic-Mobert, it never got to construction, but we were going to try the CLT building, so that everything was going to be built off-site, and we would have the foundation built in Pic-Mobert I believe in the fall, which is June, and then and then start construction the following year to complete the buildings. And I know that a colleague of mine built modular homes to the passive house level in British Columbia, and they had to be, I think, shipped to the site on a boat, barged to the site, and they were completed quite quickly, and that's exactly where passive house makes the most sense. Makes the most sense for larger buildings and Indigenous, lower income families, anybody who isn't getting, where heating is costing them a fortune every month, that if you don't have to think about what those things are, you can spend your time and energy worrying about more important things like your family and the life that you're living, right? So I think they are starting to do that. It's complex. Going through the process in Pic-Mobert was an up and down experience, and hopefully in the future we'll be able to do more work with Indigenous groups up there.
Thank you. Miigwech.
Thank you. Yes?
Hi, thank you. That was a great presentation. I'm curious about cost. What for like an average Canadian home, residential, detached, built to current, building code versus passive house, and then a cost comparison between a high-rise, multifamily built to today's building code versus passive house. If you could give us a general sense of what's the premium.
It's going to be a little complicated answer. So right now we're still in infancy of people doing passive house on a regular basis. And if you're building a passive house, the standard is so strict that you have to have all these consultants up front. So it's like you're paying for the more expensive cell phone to get the cheaper monthly rate. So if you're doing a custom home, it's still a custom home. And you've paid for the mechanical engineer now, because most homes don't get designed with a mechanical engineer unless they're passive house. So you're adding complexity there. And so that it doesn't translate well. So when I say that it can be affordable, it can be the same price if you're buying you're choosing an Aiken frame home that is already designed to that standard. You're choosing the rammed earth house that's already been designed to the passive house standard. Those costs of all those consultants are spread out over all the people that are going to buy that house. So you're no longer in the same place as you were. So I can build you a rammed earth house that costs a fortune, or I can give you a rammed earth house that's passive house that costs less than an average code-built home. So once again, it's the way you build the building that makes the difference. And I think, I'm not trying to talk architects and engineers out of a job, but maybe we're designing less custom homes and buildings than we are other things. On high-rises, because of the surface area difference between a little tiny home and a big building and the number of people, passive house makes the most sense. It costs less from the building point of view, because you're going to have a mechanical system that's much smaller. You're going to have things, I always think the only part of passive that's passive is the insulation. So it's the amount of insulation is going to be greater, but all that money you're spending on extra insulation and windows is going to reduce your need for the complex things like the mechanical systems in that building. So there's more opportunity. But definitely, I would say there's zero cost difference for high-rises. I see Logman there again.
Thank you, Terrell. That was wonderful presentation.
Thank you.
And my question is the familiar one, because we're working on a house, single-family house, and multi-unit buildings, and regardless of the scale, the battle is with the developer and the homeowner, is to decide on the heating and cooling system.
I know.
And no matter how hard we try to describe the advantages of energy efficient system, clean system, we are forced to use conventional system, which is a forcer system. And you know that a few years ago, we were trying to get HRV into houses, and nobody was willing to pay for it. Now they have to do it because it's in the building code.
Absolutely.
So if you can just talk about how you handle
How do I handle that?
Be great.
I've been lucky on the larger buildings that I've worked on that everyone was trying to meet a standard. So getting people on board with the standard that you're trying to meet limits the options. It's kind of like picking the prefab house. You can't make a change or it costs a lot of money. In high-rises, and this is where other people are far, like you're talking mechanicals with an architect, really not a great place for me. It's not my place. But what I've understood is that there's a choice between a system that works for the whole building on a large project, and then the ones where each individual unit is its own energy supplier, sorter, and the only thing you have to really deal with is the water coming in and the waste going out. So I've worked on projects where they were for retirement homes, where we use something, what we call a magic box. It does the heating, the cooling, the ventilation, and the hot water in one little compartment. So that's been, because it's not distributed through the whole building, you're not having all those huge ducts, you're not having the interconnectivity between different units, none of the fire stopping is required, but then the architects don't like it because there's all these holes on the outside of the building because every single unit has an in and an out. And I kind of like that, and I'm sure that there are some mechanical engineers that will get mad at me or not like that, but in some situations I find, especially when we're talking about modular buildings, I would say that Marriott probably has one of those magic boxes in it, doing all the work because they want to have it plugged in, clicked, hallways are already done, outside's already done, and so I think that's preferable there. Telling a client in a passive house that radiant heating is a waste of money would be a good start because you can't feel it. So sometimes with my clients, I try to describe why radiant heating doesn't work in a passive house, but they really, really want it. And I said, what do you want about radiant heating? It's warm feet. Well, you're not going to get that in a passive house because the house is so, the temperature level is such the same that you're never going to feel that heat. So I said, well, then put an electric mat in the 2 rooms that you're going to use that in, which is the bathroom or in another space that you really want to use it in, and don't spend the $30,000 on that radiant system that you're never going to use. So the nice thing about passive houses, you get to a level of energy use where in southern Ontario you can make choices that don't always make sense. So I have a building that's run electrically because I've already reduced the use by 90%. So even if the price of electricity is high, I pay less than all of my neighbors to run my house electrically. So you have more opportunities to do things. Several of the buildings I've done recently have air-to-air heat exchangers. So we're kind of like air conditioning, but it's a little bit more sophisticated. But I always find that things like that, like the very sophisticated mechanical systems, need to come with the engineer. They need to sit in the closet and fix it every time it breaks. Or we don't understand which button to push to make it do what it does. Because how many people, other than the environmental geeks that we are, go in and actually clean the filters? So I have houses where I've used electric baseboards because it's dead dumb. So yeah, you got choices. What your client chooses is not always the best, is it? But you try and make those things happen in your favor. Give them less choices.
Thank you.
Thanks.
Okay.
Okay, thank you.